Discuss this question.
Okay, so now that you've done some experiments, which kind of lavas do you think you'd find in a cone volcano? Thick. Why? Why do you think that? Ah, so he says it kind of stays still. It will eventually build up on itself, right? Okay.
So were you able to figure out anything about what kind of lava comes from each volcano? Which kind of volcano has the thin, runny kind of lava? The lava on the left. Well, let's imagine a crack in the ground. And let's imagine that lava is shooting out of it. If that lava is thin and runny, it will flow nice and smoothly, and it will spread out into a big pile, just like in your experiment when you spooned your thin lava onto the plate. Doesn't this shape look familiar? Thin lava forms shield volcanoes. But imagine that the lava shooting out of the crack was thick and pasty instead. Because it's thick and pasty, it can't flow as easily when it comes out. So instead of spreading out, it will just kind of fall down into a pile. Splat. It piles up into a tall mountain shape, a cone. Look familiar? Thick lava forms cone volcanoes, just like it did in your experiment. So now you understand the differences between these two volcanoes. Shield volcanoes have a thin, runny lava that cools into a dark colored basalt rock. And cone volcanoes have the thick, pasty lava that cools into the pale calcite rock. But this only explains the shapes of the volcanoes. What we still don't know is why do cone volcanoes sometimes explode the way this one is doing here? The answer to this question is in the bubbles. Let me explain why we had you blow bubbles in your experiment. Inside a volcano is mostly melted liquid rock, but it sometimes also has gases in it, which make bubbles in the lava. So imagine you could look inside of a shield volcano like this, which has thin lava. When bubbles form in thin lava, they travel up to the top pretty quickly and they pop. You saw the same thing when you blew bubbles in thin lava in your experiment. Lots of bubbles reached the top really quickly. Plus, it was really easy to blow the bubbles. That's important to notice. The bubbles didn't have any trouble at all escaping the thin liquid and then popping at the top. But in thick lava, something different happens. Imagine we could look inside of a cone volcano now, which has thick lava. This is the kind of volcano that explodes, remember? This type of lava doesn't flow very well, and the thick and pasty lava tends to plug up the top of the volcano. It forms kind of hard crust at the top. When bubbles form in this lava, watch what happens. Can't escape, and more bubbles will come, but they'll all get trapped at the top. The bubbles try to escape, but they can't. So pressure builds up and builds up, and this can go on for months, years, sometimes even hundreds of years, until one day the pressure is too great and boom, the volcano explodes. You saw the same thing in your experiment. It was hard to blow bubbles in the thick lava. You couldn't even see the bubbles for a while. All the bubbles were trapped under the surface until, boom, all the bubbles exploded out all at once. Bubbles in thick lava are the reason why the cone volcanoes explode. So we've solved the mystery. Let's look at that picture of Mount St. Helens again. Before it exploded, remember, and then after. So now we can understand. The thick lava inside the volcano trapped so many bubbles that the top and sides of the volcano eventually blew out, sending bits of hot rock everywhere. Now you may think that once a volcano like this has exploded, that's the end of its story, but it's not. In the time since 1980, since the eruption, Mount St. Helens has been slowly building itself back up again. Look at this. You see that? There's a little baby cone volcano forming right in the middle of the old explosion spot. It'll surely be a long time before the pressure inside this gets too great, but one day Mount St. Helens will explode again.
Okay, so we've completed it. So let's talk about it. Okay, why in a cone? Why does it explode then? What happens to create it to explode? Yes. Okay, good. So that gas underneath it, those gas bubbles, they get caught, right? Because it's thick. And so they build up, they get caught. As they build up, build up, build up, build up. How many of you have ever shaken a soda can before? Guess what you're doing? Building up the pressure in the with the gas bubbles in there, right? The minute you open it, what happens? Right? Because it wants to go to low pressure. High pressure wants to go to low pressure. Okay. So, and then with the shield volcanoes, right? It just those bubbles come up and then they just flow out. Okay, not causing it to explode. Okay, good job. So we're gonna clean up and then you can finish, you can take the last 6 minutes to fill in your work on the lava experiment paper.